Okay. We are going to actually let's do a little recap on where we are. So we've done 3 streams so far, and the first one we built a basic NIO server, non-blocking IO server, and what that essentially means is that we are multiplexing, or NIO is a way to multiplex multiple client connections over a single thread, right? So if you've ever used Netty on the JVM or Node.js, this is how it works, what it does, and this is a good thing from a efficiency standpoint. However, it introduces some interesting challenges for the programmer, right? It introduces the async model where you cannot block the IO thread, as they call it in Node.js, or you have to be very careful, and if you need to do some blocking work, you have to either do that in a different thread and signal back when you're done, or you have to make all of your clients and all of your work async. Okay, so that's what we did in number 1. Number 2, we took that a little bit further, and actually the important thing is here we only accepted connections. We didn't do anything else. So number 2, we kept going, and we basically allowed for reading data off the client connections, and so we introduced at that point, so we had a server, and then the next thing that we introduced was a second thread to read data off the connections, right? So right now we have one thread to accept connections, and then we added one thread to read data from connections, right? And so that way, if someone decides to send us a giant file or something like that, we are not blocking the acceptance of new connections, right? So that's what we did in number 2. And then number 3, we broke that out, and we went a little further, and we actually are reading data in chunks from the client, right? So let's take a look at that. So we have a that's not what I want. We have a client and a server, and we can run this server, and it is always listening for connections on a single thread. And again, we register for accept events, meaning this thread is only interested in what happens when you accept something. And when we get in a client, we then accept that connection, and then we register what are called the read events, meaning we want to know on this server reader, right, this separate thread, this is the thing that actually iterates and wakes up for things that read, right? So again, we have one server, and actually what we can do is we can call this so we have server reader, server acceptor, because again, this server only accepts channels, and this will only accept, yes, that's fine. I don't know why it took so long to do that. So let's go ahead and run this just so that we can see and remember where we were. All right, so just like I said, we've got there's two threads that started up, right? So right now we have one reader thread. So the acceptor reader thread is running, and it's basically waiting for a new client to be passed to it, and it will read any data off of those client connections. And then we have a server acceptor socket, which listens on 10.301 and accepts any connections, right? And as you can see, actually, we're going to debug this just so that people can get a sense for what's doing. This loop is constantly running, and every second it's essentially waking up, and it's not getting any inbound connections, right? So we can remove this. So this thread is constantly running, waiting for someone to connect to it. Then when we do get someone that wants to connect, we will get down in here and we will put a breakpoint here, and we'll see what happens. So from our client, we're just basically getting a socket to the server that we know is open on 10.301. We're going to get the output stream, and then we're going to write a bunch of stuff to it. Let's do this to make it easier to see what's going on. So we were looking at buffering. So we sent a giant message earlier, but let's do this. So this is, we're going to call this long, right? And then we can also do a short val, short. Message dot to byte array char standard char sets dot utf8. All right, so we're just going to write this short message. So our server is running, and we'll just go ahead and run this client. And what we're going to see is we're going to get a acceptance on the server, right? So server here, it accepted. From localhost, the port that we got a connection from is 55536, so that's this socket over here. And what we're doing is we're going to say the server reader instance that we have, this other thread that's running in parallel with our acceptance, we want to register for read events on that. And there's a client ID, which is just some extra information that we can attach to read that, right? So we're going to go ahead and let that through. And so we are, and then what happens is once that breakpoint went through, this client sent some information. It says, hello, this is a short message. This server reader got it, right? It says it got 29 bytes from this thing, and it says, hello, this is a short message. Now, just to illustrate that this is continuing to run, I'm going to run this client again while the server's still running. I'm going to clear this input, and it's going to send one message, right? And if you look at the server acceptor, right, it got a message on the reader thread specifically. It got 29 bytes, and then it got a payload. And so now we're blocked on this client thing, and if we send another message through, it will send another message through and get another payload, right? So we have a server that can accept input from multiple clients, and actually, let's actually do that just to prove that it does. So we're going to have one client, and then actually what we're going to do is we're going to run this thing again, another instance of it, and it should be on a different socket and a different client, right? So we got one connection from localhost 53, and then one connection from 57. Or actually, no, this is the old stuff. So we got a connection from 57 and then 61, right? So we can get connections from multiple clients. It's accepted all in a single thread. and then it's the client can read it and then output that. So that works. But what we would like to do, and what we've been talking about doing, is essentially making this very basic echo server. So what that means is that the server will just echo whatever back to the client that it got off of the stream, right? So let's go ahead and start working towards that, right? So we're going to remove this stuff, and let's think this through a little bit. So we're going to assume, and we're going to make our own little protocol here just for testing purposes, right? So we're going to assume that the first we're going to assume that the client is going to send us a command, right? Think of this like an RPC server, right? So a client will send a payload that looks like something like this. It'll say echo, it'll have a space, right? The space will be very important. It'll then have the message that it wants to echo. So this is the message I want to echo. And then we'll always be looking for a new line character at the end to tell us that this is the end of the message, and to stop and continue going, right? And so you can imagine, right, you need that terminator, because if this is a really long message that might take up multiple buffers, and I want to have it all echoed back to me, right? We need that. And so this is something that we looked at in the last stream, was that when we're reading data, right, we can allocate a byte buffer. And again, because we want to multiplex, if we have client 1 and they send us, say, 5 kilobytes of data, but then client 2 comes in and sends us 10 megabytes, and then client 3 comes in right afterwards around the same time, and they only send us 5 kilobytes, we don't want to block, right, this reader thread waiting for this entire 10 megabyte file to get to us, because if we do that, if we block here, right, then basically all of the clients that come in afterwards that might have, small little payloads get blocked, right? So that's not good, that's not efficient, and so we don't want that, right? And so when we read, every time the underlying OS says that this client or this connection has data on it that's readable, again, this thing wakes up, it passes us this key, and then we grab this byte buffer, and right now, right, what we're doing is we're doing exactly this. So if someone sends us 10 megabytes worth of data, we are actually, are we? Did we change this? We know this is more than we're sending. Oh yeah, we'll deal with multiple buffers later, right? Yeah, we have a comment here, right? So, so what we're gonna do is tweak this value down, and we're only gonna read like 32 bytes at a time, right? And so this is good from a you can think of this as how much do we want to buffer per message, right? And you can tweak this, it doesn't really matter what it is, but again, if someone sends us 32 kilobytes, right, that means all of their message can be read in one go. But if someone sends us this, right, 10 megabytes, and then someone after this sends us 32, right, the way that this is actually going to look, so we're going to say this is what is sent to the server, and basically then we can look at, we can say this is what the server is actually doing, right? and we'll debug this. But basically what'll happen is client 1, it'll read 32 kilobits, and this at the moment should be able to echo back right away, right, in theory. And then in client 2, since they sent us 10 megabytes, we're only going to be able to read 32 kilobits, right, and then return control back to the loop. Client 3 will read 32 kilobits, and then basically we can echo back right away. But then it's going to come back, and client 2 is going to read 32 kilobits. You know, keep doing this, right, until it has all the data, right? There'll be a couple of these, and then client this will basically we will have read the /n character after 10 megabytes, and then we can echo back, right? So again, we are multiplexing, right? This is a single thread, so we can't block, and we're multiplexing all of the incoming clients, buffering this data up in some buffer right in here, and then we return afterwards. So, you know, we left this comment in here. We said we know at the time this was 512. We know this is more than what we're sending. We'll deal with multiple buffers later. Now is the time to remove that and start dealing with that. So what we're gonna do, we're actually gonna make this buffer really small, just so that this is very, very, very simple to see what is going on. So we're gonna send one message. This is more than 8 bytes. And what we're going to see is that this entire message that we sent actually gets chunked and read in multiple things, and so we can't technically echo it back right now in one go. So let's go ahead and run this, and we will see what this looks like. All right, so server's up and running. We're going to send this client, and basically what we're going to see is that we're going to see a couple different messages. I think it's like 20 some K or something like that. But this will run. It runs to completion, and then let's see what we got on the server. Did I close the wrong thing? Oh yeah, here we go. So you'll see on the server, this message was chunked. It only read 8 bytes at a time, right? So it read up to the TH, right? That's 8 bytes. It read another 8 bytes, read another 8 bytes until it got to the end, right? There was nothing else at the end, or nothing more that it could read, and then it was done. But the problem is we need to keep track of this buffer per client, so that we can echo this back when we're done, right? So we're going to change the behavior of this so that we, one, are looking for the actual end of the message, right? So we're going to, again, we said from our protocol that we're going to assume some command, a space, right? And then they're going to send their message, and then we're going to do \n. So we're going to put that in there. So basically what we're going to do is we're going to change this so that it continues to read, and then when it sees \n, then it will print out, this is the entire payload that I got from the client, right? So rather than printing this out every single time, we will say red bytes. We're basically going to check if buffer dot get char at bytes read equals that, then we print the message. Otherwise, we're just going to loop, and let's just test this a little bit here. So print, we have more info, more to read. And then this is going to go here. Eventually, this will go here. But you know, again, we're not storing this buffer per client. So this is basically just going to read, and what we should see, if this is working right, which it may not, we might have to fix that. I haven't done that in a long time. What is this complaining about? Yeah, we can just replace this with that in Kotlin. We got to the end of the message. So if we do this, we should see 1, 2, 3, 4 payloads. So 4, we have more to read. And then we should see, or 3 more to read, and then an end of the message. So let's rerun the server and see what we get. Close that. So send this data over. That'll run to completion. Ooh, what did we do? Yeah. It's that. Let's run this again. Client's done. So we read 8 bytes, and then we got another buffer problem. All right, well, what the hell are we doing wrong? Dun, dun, dun. We're gonna debug this. We're probably doing something stupid, and I'm just not seeing it. All right, so client, send your data. All right, so buffer, we read 8 bytes, the buffer's full. Let's just do buffer.get this bytes read minus 1. What does that give us? What? Oh. That doesn't line up with the character. Yeah. Yeah. So this character buffer, right, is empty. Buffer dot array, right? This is a byte array, so this has 8 bytes, and this is empty. What? What? All right. This byte buffer API sucks, so I might not be using this right. Creates a view of this byte buffer as a character buffer. Okay, let's try this. Buffer.get char of 0, right? Yeah, I don't think this is gonna do the trick. Byte buffer. Okay. Dun, dun, dun. Actually, let's try this. Let's try this. Yeah, let's do the. How many? Yeah. Okay. Um, 'm gonna do. So in Java, a character I think is represented by 2 bytes, not 1 byte, and I think that's my problem. 16-bit entries. Yeah. Yep. So, actually, let's character. Yeah, interesting. Character dot. Is there like a new line? Line separator? All right, let's do this. Just for sanity's sake, let's print out each buffer and look at it and see if we can fucking make sense of this, because I don't remember how to do this. So, buffer dot array dot for each print byte it dot that. That's going to print something stupid and illegible from what I remember, but it gets us a little further. So run. False. It is not stupid and illegible. That is quite interesting. Okay. All right. Okay. So so one of these guys, this is our new line character in here. So let's see if we can at least just detect that. So let's just do something silly for now. We're going to say this is new line found equals false. And if it.toChar equals new line, we're going to say new line found equals true. Yeah, this needs to be var. And then basically if new line not found, we're going to print the character. So basically we only want to print characters prior to new line. This should get rid of the garbage, and then this then validates that our condition that we're using to say we can echo back is correct, right? So we're going to rerun that. Run the client. And yes, okay. So that's good. So we got our 8-byte chunks. It doesn't print out any garbage, and it properly says, actually, why don't we do this? It's properly set print line. Well, we don't have to do that now, we know. So we found the end of the message, right? Okay, so this is great. Okay, so we can write a for loop here. So we're going to iter over the buffer dot array, and we get a byte. Actually, we're going to want to do a for loop. We're going to want to do a normal for loop because we only want to read the number of bytes that were read. Actually, we can just make this a little cleaner. We can say buffer.array slice 0 until bytes read, right? Yep, yeah. All right. So this will ensure that we never go past the number of bytes that were read, but we still need to check, like, if for bytes, yeah. So then we can say byte dot to character equals the new line, and if it is the new line, then we found the end. Okay. All right. So now we can get rid of all this stuff. All right. So now we can run this again, and basically now we should see we found the end, and it will continue to buffer, or well, it will buffer, and then basically we should see we found the end one time. Let's see what happens. Yep. All right. So we read 6. We read 8, 8, 8, 6, and then we found the end, right? So okay. So that's working. Now, that essentially means that we can break here, and otherwise we can buffer the data into the client buffer. Okay, so this is what we've been working to get towards all along. So within this reader thread, we need to have a buffer for every client so that we can read things in 8-byte chunks, not get held up, and then at the end we'll want to pass this to our writer thread, and we may not get there, but we'll see. So again, one of the great things about this is that because this reader is single threaded, we don't need any concurrent hash map junk. We're not going to do any mutexes or locks or anything like that, right? We can just have a good old hash map. Client buffers, It's going to be a map of string to byte array. Let's think about this. Byte array. What would be easy to use, efficient, but not a total nightmare? Because what we essentially want to do is we want to easily append to the buffers without let's actually look we don't want to use byte buffer because honestly byte buffer kind of sucks. Well, maybe we do, because we can create a byte buffer by allocation, or we can wrap an existing byte array into a buffer. But the problem is that if we reallocate, that kind of sucks. So what we want is efficient allocation or efficient growth, right? So we allocate a new buffer. Is there an easy way to like copy? Not really. That's what I thought. All right, let's just do this like the stupid way first, and then we can optimize this later. So we're gonna hold this byte buffers. You're gonna spell it right. That would be good. And this is going to be map of that. All right. Okay. So we're gonna do a couple things. We're gonna call this temp buffer because that's what it is. That's our buffer that we're always reading into, and can get rid of all of this stuff. We'll probably save that code for later. We might need that. All right. So now we need to put the data into the client buffer, and let's sketch this out a little bit. So first we need to see if we actually have a buffer. So val client buff equals client buffers dot get, and we're going to use the client ID that we have, which basically identifies a client by its INET address and its port, right? So that was really important. That's why we did that, right? So that we can keep track of them very, very, very easily. And then, yeah, sure, you can be private. That's fine. Okay, so then this, yeah, that's byte buffer. So we need to say if, and this is not going to be idiomatic Kotlin code for now. This is just for easier. If it's null, client buffer equals, we're going to do byte buffer.allocate. And when we first allocate it, we're going to assume we can actually be kind of smart about this, which is kind of cool. And actually we don't want to break here, because if we have a message that's too small, it will read and then break. So what we really want is end found equals false, end found equals true. This has to be a var. All right, so we can actually be kind of intelligent creating this initial buffer, because if someone sends us in a message that's less than 8 bytes, we only need to create a buffer that's large enough for that message, because we know we're not gonna loop again. So we can say if the end has been found, then our client buffer is going to equal allocate the number of bytes read, right? So someone sends us a 7-byte message, we only need that. Actually, it's bytes read -1, because we don't care about the end character at the end. So if someone sends us 1 byte plus the backslash, plus the new line character, that's 2 bytes. And then, so if the end is found in here and we're null, that means it's a new message and we're already at the end, so we're only going to do this loop once, so that means we're good, right? Right, and then else, we're going to say the client buffer equals byte buffer.allocate, and we're just going to assume 2, right? And let's actually let's private const val buffer size equals 8. Companion objects, right? So we'll use buffer size times 2. All right, and yeah, you can clean this up for me. Okay, so we have our client buffer, which is great. Actually, we're going to say get a buffer for the client, and then we will buffer the data into the client buffer, right? Yeah, it's never used. Okay. All right. So now we can put that data into the buffer, and right now we're just copying, which is wasteful, but we can do that later, or we can fix that. Actually, what does put do? Writes the given byte into this buffer at the current position and increments. Relative bulk put method operation. This method transfers the bytes in the remaining given source buffer if there are more bytes than the minimum. So this is copying, right? So this is not the best thing in the world, but that's get it working first. So we're basically going to say, please copy over the temp buffer. Yep, that's fine. So we're going to say put that data in there, and then we're actually at the end of here, we also need to say client buffers of client ID equals the client buffer. So we got to store that in a map. Ooh, no set method. Oh, okay. Dot. is this immutable? Mutable map of? Yeah. What am I doing wrong? Oh, it's been so long. What in God's name? It's a mutable map. Oh. Yeah, it is a mutable map. Duh. Yep, that would be the problem. Client buffer, client ID equals client buffer. Okay. So now we put that in there. Cool. And we're actually gonna put this here because if the end was found, then we can end was found, right? So then in here, right, we can say echo this back to the clients, right? And since we saved our handy dandy stuff, we can pull this back in here and just print this out and make sure that we got the right thing. And this thing is going to be the client val buffer equals client buffers dot client ID yes, standard char sets. Yes, you can do that. Sure, you can do that as well. And that, no, that's just stupid. We'll just be jerks. All right. So this should, if we get to the end, work. Now the one thing that we haven't done though is that we ensure the, well, we need to do a couple more things here. We'll get there in a minute, but we'll say ensure the buffer is large enough to handle, otherwise make a new copy, right? So for now though, we're just gonna test our, kind of like new buffer thing, right? So we're just gonna say, we're gonna send a 2-byte message with that, and that basically should bail out early. If that'll bail out early, and we'll have our nice, and then actually here we can client buffers that client ID. We can get rid of that. No. Well, we can just say delete the buffer because we don't want to hold on to that thing forever. All right, let's debug this server. And so we should get a null client buffer. We should get end found. And then we should allocate the bytes read -1. We will put this, and actually what does that do? Buffer overflow if there's insufficient, yeah, this may, we probably need to say, there's probably an override for this that says like 0 to bytes read, right? Something like that. come on. Really? This is why I said this API is not awesome. Yeah, that's stupid. All right. Well, copies on top of copies on top of copies, you know? Which is just, this is awful, but we'll fix this later. But again, this byte buffer, the Java byte buffer API is not the greatest. So what are you gonna do? All right, so clients, we are going to send a 1 byte message, and bam. All right. So how many bytes have you read? We read 2 bytes. If the end has not been found, so that's 1 byte. Oh, we're reading byte, byte, byte. God damn it. Dun, dun, dun. Okay, so we gotta do this a little differently. We gotta pull this out of here. This is why a good debugger is so goddamn important. All right. But we don't know if the end is in here anymore, which kind of sucks. Because that means we really have to scan through everything to find a new line character. All right, so that's fine. That's not the worst thing in the world. Let's just do that. Well, you know what? Let's just be dumb for now. Let's just be dumb for now. We'll add this back in later. All right, just to see if this works. Okay. All right, so we're gonna rerun this. We're gonna say, because we actually have to read through the entire message that we got to determine if that, and so that may not be that great of an optimization in the end. So all right, so the client, we can send something over, and we should get in here. All right, so we've created a client buffer. The client buffer is 0 to 16. We have not found the end, and this is not 0. We really just want to put the byte. Thankfully, that's actually a method. What do you know? All right. Dun, dun, dun. Send. Bam. All right, we got that. We got a byte. The end has been found. And if the end has been found, we can set this to true, and we can also break. Because we don't necessarily need to put it in here. We've got enough room, so that's fine. So we'll just take that out. We'll keep running, right? And the end has been found. The end was found. We got here, delete the buffer. Okay. That is pretty cool. So that works. All right. So we can actually break, leave all of our, put all of our to-dos in here. To do, make buffer only the length it needs to be. If message is smaller than buffer size, right? We call it buffer size, yeah. All right, so let's take this stuff out of here. God, what is the, this is gonna make me mad. What is the method to, yeah, remove, Jesus. Oh boy, am I rusty. Client buffers dot remove client ID, right? So we can remove that buffer at the end. Okay, so this is pretty much back to where we were. And we're also, you know, effectively, so yeah, so we're back to where we were, but we have the ability to actually buffer messages, right? So now, so let's just run this again just to make sure that everything we've messed with didn't break anything. But so we should see one message that's just an H, right? Yeah, we can get rid of the breakpoints, get rid of all the breakpoints, right? So yeah, we got one message just an H, but we don't want to put this thing in here, which we'll fix in a moment. Why did that put that byte? Oh yeah, because this needs to be not until bytes read, but client buffer dot position. Yeah, let me think about that. I'll be right back. I will be right back. Okay. All right, so we're back. Okay, so yeah, so there's still a couple. There's one little problem with this here, and that is that this buffer that we're reading, let's just do this a little bit so it's easier to read. So when we read out of our buffer, we're we are doing that based on bytes read, which is incorrect. So a byte buffer actually keeps track of some things, right? So a byte buffer has some internal things in it, and it basically has, well, here we'll run it and we'll show you. So we'll run the server again. So byte buffer actually keeps track of some things internally, which is great, but it's also one of the reasons why it's a pain in the ass to use. So you will see here, right, position, limit, cap, right? So the byte buffer, as you write into it, it increments the position, which is awesome because then you don't have to necessarily keep track of how many things are in it if you didn't write everything into it, right? So our client buffer, right, only has one thing in it, so buffer.position 0, right? So when we capture it and we want to print it back out, we need to use buffer.position, not anything else, right? So so that was important. So now, right, payload is H. Awesome. So this is a new message that is longer than 8 bytes. All right. So now, actually, let's do this. Just to illustrate this. 1, 2, 3, 4, 5, 6, 7. So this should all come in through one payload, and then print out 1, 2, 3, 4, 5, 6, 7. If we don't have some stupid off by 1 error, which is very possible. Nope, we're good. Okay. Now, if we send more, we will blow up because we need to allocate a new buffer. So if we put 8 and we send it over, it will not be happy. Huh? What is this fucking voodoo? Why does this work? Oh, because we do 16. Good God. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if we, so this will work. So 16 will work. Oh my goodness. Computers. 16 will work. And it will read 8 bytes, and then print out the entire payload. But if we send that, this will not be good. It will not give us the right thing, or it will blow up. Yes, buffer overflow exception. Okay. So basically, we have a buffer of 16 bytes, and trying to put too much into it, right? Because here we're not ensuring that the buffer is large enough to handle the new thing. So if we send that over, if we send this, what in the world? Oh yeah, that thread's dead. Yeah, we got to rerun the server. That thread is dead, yo. All right, so we're gonna run this. We're gonna get 1 set of bytes, 2 set of bytes, and see here, right? Limit 16, capacity 16. We can't write anything more into this buffer. So we're at limit 16, cap 16, and now we're about to put another byte in. And, oh, well, this is going to go 16 by 16. So this is going to be, yeah. So once we get up to position 16, or 15, so here, one more time, this is going to blow up, right? Because we're at 16. We don't have any more room to store. And boom, we blow up, right? So we need to do our resizing. All right, so this will be the last thing we'll do today. We'll probably save the copy optimization stuff for later. So we need to check. So if the client buffer dot position equals client buffer dot capacity, yeah. Then we need to resize the buffer. Cannot access position. It is invisible. What? Oh, yeah. Oh. Okay, they're methods. They're methods. Fine. Fine. All right. And for now, we'll do this. This is bad. Don't do this. But we're going to do it anyways. Whatever. This won't work. All right. So resize the buffer. So we will. What I think I'm going to do here is just create a new buffer that's double the size of the old one. I think that's pretty common. We'll just do that. So val new buffer equals byte buff dot allocate the capacity is going to be the client buffer size dot capacity times 2. Okay, and then basically new buffer dot put client buffer. That should have plenty of room for the entire buffer, and then basically client buffers client ID equals new buffer. Cool. And then we also need to set client buffer to new buffer so that when this write goes through, that works. All right, so let's see what happens there. Let's just do the debug thing. Okay, we're gonna send that message over, and we will hit this when our position is 16 and our capacity is 16. We're gonna create a new buffer that's gonna be 32 bytes long. We're gonna put that data in there, which means the new buffer should have 16. Why? Transfers the bytes remaining in the given source buffer if there are any bytes remaining. No, that's not cool, because new buffer or client buffer dot remaining is going to be 0. That's not what we wanted. Let's just do this for now. Basically the position wasn't set correctly. So we're gonna have to look at that put method, because that put method may be incorrect. Because what we want is we want our new buffer to have a position of 16, meaning there's now been 16 bytes added to it, and we have 16 things remaining, right? So now we get that's in there. We go through and we get our bigger payload, right? So now we can send however big of a size payload we want, and this should work. It will reallocate as needed. And if we write the new long message and we're not, and we send the terminal character, we should see that work correctly. Yep. So that's what we got. So that is pretty awesome. So that works, right? So again, we're reading these in 8-byte chunks. We read to read that message in a whole bunch of chunks, and we were able to do this. So this is also interesting. If I send this before the short message, right? Remember we were talking about how, you know, if someone sends this, we're fine, but if someone sends this, this client's going to block. Well, if we send this long message, right, what we're going to see is we'll read some bytes from the long. We'll read 8 bytes, then we'll read 16. It will actually print that message out, and then it'll keep reading it, right? So this kind of proves that we are multiplexing and being like a good citizen, if you will, right? So let's just look at that, because that is a very important thing, right? So let's clear this so it's easier to see what's going on. All right, so we got a bunch of stuff. Is our multiplexing not working right? 7, 8. Oh, that's no bueno. Oh, it's because it's from the same socket. That is not good. Yeah. So this needs to be, sorry about that. This needs to be socket 1. This needs to be input 1. This needs to be, so input 1 is going to write long, and then we're going to do socket 2 equals socket localhost 10.301 val input 2 equals socket 2 dot get output stream. Input 2 is going to write the short message. Yeah, okay, so we're going to do 2 messages right away, and this isn't necessarily the best test because this doesn't guarantee that this will do what we want, but this should, right? Because it should get all the information and then buffer. And so let's take a look at what we saw, right? So we're reading a ton of bytes, right? And then, yeah. Okay, this is working right. So we are reading a ton of bytes from this one client. Then we get this other payload, right? So 383938, right? And so basically, even while we're processing and still reading off of this other socket from this client that's sending us a much longer message, we get this payload and we're able to print it out so that this other client that's sending us a ton of big stuff isn't blocking us, but that we still eventually get to this thing, right? So we are properly sharing between our clients, right? We are, effectively, if someone sends us a giant message, and this will make this a lot easier to read. If someone sends us a giant message and a whole bunch of other people send us little messages, we can still process everyone's message kind of in an efficient fashion, right? So if we run this again, this will be a little easier to read, right? So again, we're time sharing, right? So we read 8, read 9, read 9, boom, payload from a given client, right? And actually, let's put the client ID here, right? So that we see that. So that message is going to be sent, right? So again, we're reading a whole bunch of bytes, reading a whole bunch of bytes. Our little client is 56694, right? So we would have read from them 3 times, actually more than 3 times, right? So yeah, no, 3 times. 8 bytes, 8 bytes, 8 bytes, right? Then that message is fully completed and fully read so that we can print that out right away. And then we have to continue to read from the other person, the other client, right? And then at the end we print that out, right? So if we look back, we have effectively done this, right? We're able to, you know, we haven't echoed back yet, but we have a loop and we have proper multiplexing, and we can actually do this, right? So our server is a little further along, right? So we're going to save this echoing thing for next time, where we'll create our 3rd thread, which will be our writer thread. But we now have, you know, proper multiplexing sharing, which is pretty awesome. Actually, you know what? Let's well, yeah, let's just clean this up a little bit. So we're gonna leave these to-dos in here because maybe we'll do that next time. Yeah, we'll leave all of this in here. We can get rid of this. Yeah, so let's just make sure to break anything. What I was going to say is we could go back and make the buffer only the length that it needs to be if the message is smaller than buffer size, but I am hungry, so I'm going to go get some lunch. So, yep, we didn't break anything. We're fine. Cool. Awesome. Well, all right, so I think that's a good point to stop. I will commit this right now. And I will also tag it as well. Oops. So we're basically now buffering client messages until we see the new line character. Cool. So we're gonna, we can commit and push that. Yes, the to-do is fine. Push. And then we're going to, I don't even remember how I'm tagging these. How am I tagging these? Streams 2. Okay, all right, so we're gonna do git tag stream 4. And we're done. Cool. I think, yeah, git tag. Yep. Yeah, we're good. Okay. All right. That is it. See you later.